You can see the slides okay, just great. Is that great?
Yes.
Awesome. So yes, if you read my Twitter, you'll get a hint. I think a lot of you will probably find out what this Easter egg is. So I look forward to see who finds it out first. So I'm excited to be here. SAS is absolutely one of my most favorite conferences to go to, and I'm glad I could be with you like we are together at conferences these days. Um, I often feel like as defenders, we hear about attacks at the same time, and yet we defend alone. And this process of learning to defend, it's really an experience-driven profession. Like, it is the school of hard knocks. You have to do it. You have to slog through the data. You have to analyze in order to get good at this business. And, if it takes 10,000 hours to make an expert, we need more experts sooner in this profession for sure. So what I wanted to talk about today was a set of ideas that I think many of them will be familiar to you all, but I think if we embrace these together as a community, they can sort of lower the cost and speed the journey of that path to mastery. And so with that, I'll go ahead and get started. So there's this quote that I really love because it really is got community at the heart of it, which is, if you want to go fast, go alone. And if you want to go far, go together. And I often feel, like I said in InfoSec, we are defending our networks, our assets, our users alone. And yet when we are able to come together as a community, there is a lot of power in that. So, and this talk really talks about harnessing the power of that community. So my talk has 4 sections. I'm going to start with talking about knowledge and how vital that is to defense. And then, knowledge by itself is great, but it doesn't do anything in the real world. It doesn't necessarily speed or detect anything by itself. And so you need to make that knowledge somehow executable. And I'll talk about the Sigma project. And then, like I said, the process of analyzing things as a defender is a lot of slogging through data, pivoting, enriching stuff, and then you come out with your conclusion. And if you hear some of the speakers, you go, "Wow, that's amazing what you discovered." How could one repeat that? How could one do what that expert did? And how do you make it so that expertise can be packaged up and used by others? And I'll talk about how Jupyter Notebooks is an open source technology. I think plays a vital role there. And then also just how important community is through all of this. So let's start with organized knowledge. The eyes can't see what the mind doesn't know. And so with that, one of the biggest contributions to InfoSec in the last 5 or 10 years has been MITRE ATT&CK. I'm sure it's familiar to all of you. And it is not trying to be an attack technique database of every possible theoretical attack, but really the ones seen in the real world to help defenders prioritize. Each one of these techniques has a lot of detail behind it. I have some of my favorites here. This is one of my favorites, which is an attack abusing accessibility features in the operating system. There's this attack technique called the sticky keys attack. And if you've ever heard about that one, it's a nifty way that attackers, red teams, pen testers, or real life attackers can leave a backdoor presence on a machine by abusing accessibility applets. So obviously MITRE ATT&CK has all these techniques documented in it. And one thing that this attack navigator tool allows you to do is go in and select particular APT groups and then see which subset of MITRE ATT&CK are they known to use in their attacks. And I like these things because they allow defenders to prioritize. The reality is you don't have to defend against all of these techniques. Defenders face certain persistent threat actors, and you want to be good, especially at those kinds of techniques. And so this allows you can think of this like applying a heat map of which areas should you make sure you have good event collection coverage, analytic coverage, and whatnot to help defenders prioritize. And I kind of hope one day, I know many in threat intel that consume threat intel would wish we would all just get together and call the same group the same names. I'm not quite sure that is going to happen, although we often have our AKAs for different threat groups. But I think what we could probably all do together as a community is publish the subset of the MITRE techniques that the threat groups we do track, what techniques they're seen to operate in. And that could help defenders say, okay, I need to worry about this one or that one, and let's see how I'm doing against it. So MITRE ATT&CK a lot of it is really aimed at what we'd call the traditional enterprise, think Active Directory, servers, endpoints, and so forth. And then most environments are operating in a world of cloud. And certainly in this remote work world, we're operating in a world of SaaS services and cloud for sure. And so what does a MITRE attack look like where your network is really composed of a lot of cloud services? Well, if you go back in time, somewhere around 2016, there was a turning point for Office 365 that we noticed where, Office 365 was widely used, and it was sort of a little under the radar for researchers for a time. And then starting a few years ago, every month there was a new blog, a new tool, a new presentation of how to do attack techniques against an Office 365 tenant, how to do reconnaissance, how to go exfiltrate data and tooling and so forth. And also, in addition to researcher, red team interest in it, companies like Mandiant FireEye, CrowdStrike, Microsoft's own incident response team called DART started to publish details about threat actors going after tenant data in Office 365. So a lot of interest in attack techniques here. They're clearly going to be similar maybe in spirit to what you see on an enterprise network, but they're going to be different in what the tooling looks like and how they manifest, what the logs are, how you would detect them for a defender. So if you were to take a sort of a set of techniques, this was a snapshot at a particular point in time last year, and take these attack techniques, all of these ones on here are all linked to open source tools or blogs that are published. So I'm sure there's more than that are not public, but these are all the ones that are out there that are public. And if you're operating and use this service as a defender, you need to know about all these things and understand, do you have coverage for them? Do you know how to investigate them and so forth? And so, and every SaaS service are going to have things like this that are analogous for us. So if you want to make defenders' life simpler, I guess what I would say here is we could publish more blogs and have more web pages where these things are documented. But I think to make defenders' life simpler, the right thing to do is, as knowledge is gained in how attack techniques evolve, especially the different kinds of surfaces and networks, the right thing to do is to go put that knowledge into the MITRE attack framework. And actually last year, Microsoft contributed a number of techniques, and you can go into MITRE and you see the bottom right, there's a drop down where you can say, show me the techniques that apply to the Office 365 platform or the Azure AD platform. And you can see some of these things here that I talked about. So it's just one idea, I think, as defenders, if we want to simplify what it takes for a defender to get started and understand the universe of attack techniques they need to think about and apply to their network, people coming together and contributing those into a common framework, I think, is going to simplify the knowledge that people need to gain in order to defend. All right. So that's knowledge. Knowledge is certainly foundational, but knowledge doesn't do anything by itself. It doesn't find anything by itself, and you need to somehow make that know-how executable. So I want to talk about a way to do that. So let me start with an advisory. This was an advisory put out a few years ago about some activity targeting the energy and critical infrastructure sector. It was actually a very good advisory in the sense that it had a lot of detail for defenders. Of course, it had IP addresses and domains and so forth. If you look on the right is a screenshot of a batch file they saw the attackers using to add some backdoors, weaken security settings, do some enumeration. So there's a lot of stuff on the right that as a defender, I can go look and see if this is happening to me. Some of these attack tools are going to leave fingerprints in the registry. I'll go look for those. Some of them are going to add backdoor admin accounts. I can go look at group membership changes. Just the sequence of commands in this batch file, you can go look in your process creation logs and see, are these things happening to me? So a lot of great detail here. And I would say, and yet this is fairly typical even these days, which is all of that translation of the information here to the particular defensive system that organizations use, to their SIEM, to their Splunk, to their Elasticsearch. That's homework for every defender everywhere. And wouldn't it be better if just that we could package up the detection logic for this? So, I mean, clearly all the analysis has been done on this attack. Package up the detection logic for this so that we can go get started looking for these behaviors, not just these IOCs. So a great project that I think really helps with this is called the Sigma project. There's two real key people behind it, Florian Roth and Thomas Patsky. And what Sigma is it's like a Swiss Army knife of applying rules for your SIEM. And if everybody here I know knows Yara and is familiar with it, well, the idea is, Sigma is for SIEM and logs as sort of Yara is for files. And it's a generic language that can use to describe detection logic, and then you can go apply that detection logic to your particular SIEM. So if you kind of drill in here a little bit, it's all on GitHub. You can go see the universe of rules that they've created. They're all defined in using YAML. So these are a bunch of rules for Sysmon that know how to look for specific kinds of attacks in Sysmon collected data. And then this is what a YAML rule looks like. I mentioned the sticky keys attack earlier. This is what the sticky keys attack looks like. It sets some registry keys because it's all about configuring and hijacking the debugger for the accessibility applets and so forth. So this is what the detection logic looks like. One nice thing about this detection logic is because it's written in YAML in a generic language, it's kind of very clear what it's trying to do and what it's trying to detect. When you often see a detection for something in a specific application or SIEM, that's written to its specific data model with its specific query language, and it's often, I don't want to say muddled, but it is intermixed with, sort of the language and the syntax of that. Whereas this is almost a more self-documenting way for what this detection logic is. You can see the tags at the top, it links back to the MITRE ATT&CK categories that this applies to. Now, I mentioned, okay, it's a YAML-defined detection logic. You might say, well, great, who cares? My SIEM doesn't use that. It doesn't talk like that. So what's the point of that? Well, that's the other part of the Sigma project. So if one part is a bunch of out-of-the-box rules, the other is translators that can translate that detection logic into a variety of backends that are common to find in lots of Defender organizations. You see some on the list here: Splunk, Kibana, Elasticsearch, Defender ATP, you name it. So there's a lot of flexibility to go from the generic language and translate it to the specifics of a network. There's a tool at this website where on the left, you can go pick any of the Sigma rules that are there, and then sort of on the right say, all right, I want this translated into, Splunk or this tool or this language, and hit the button and it does this conversion for you. So it makes it really easy in order to kind of either you can start with the rule here, tweak it live in this web page, and then see what the conversion looks like. Take that converted rule, put it into your tool, and now you're off and you're hunting. So I hope you get a sense of how Sigma rules really help fill a very useful place in making that detection logic for those techniques very concrete in a way where you can go action them immediately. So another thing I want to mention on this topic is detection rules are great, but they really need to be fine-tuned with data. And so open source data sets, I think, are also very important to how people can fine-tune these rules to make sure that they find what they need to find and don't find anything that's unrelated and have false positives. So there's a few projects I wanted to spotlight here. So Roberto Rodriguez, Cyber War Dog, he has an open source project called Mordor, and it's basically a set of data sets taken from adversary simulation. So he'll take an adversary like an APT3 data set, APT29, and so forth, and then run their simulated attacks and then capture all of the events for those. And then those are available for threat hunters to then go, try their Sigma rules against it, hunt against it, and you name it. So data sets are critical. And then another open source repository is by Samir at Elastic, and Samir is a security researcher there. And essentially what Samir has done is, if you think, all right, there's a new version of Mimikatz or another new attack tool you read about today, and you want to build detection for it, well, wouldn't it be nice if somebody already ran that tool, got the fingerprints that it leaves in the event logs, and then save that off for you so you could, go author that detection? Well, that's what this project does. And you can see the coverage of TTPs and tools that Samir has done to make it easy for defenders to get, a specific event log data set to go do some rule testing against. So, and then Microsoft, we've published a data set on IoT attack data. Often those devices all run Linux. And so this is a data set that we published that has over 125,000 different Unix, Linux command sequences that we've seen in this set of honeypots that we operate. So data sets are crucial and vital to speeding the process of writing detection rules. And more open source contributions there, I think, is very important. Okay, so that's about executable know-how. Let me go into repeatable analysis here. So let's see, this is time for a poll here and find out how many people have heard of the Jupyter Notebook project before. I wonder if we can see how many people have heard about this tool, used it. I'm curious if you used it for InfoSec. I'm often surprised how many people in the audience have used it. Curious what we'll find here. Eagerly awaiting the results. We get any good votes here and see what the progress is. All right. So one thing I find about Jupyter is for people that have been in InfoSec a long time, often it's not something they've heard about. I do find there are constituencies that have used it. So for example, anybody that's done data science and machine learning has almost certainly heard of Jupyter Notebooks. People fresh from college, it's used commonly as a teaching tool these days because a lot of computer science curriculums and so forth have a data science or machine learning class, and they use Jupyter notebooks in it. And then people that are familiar with the Python scripters commonly have heard of Jupyter notebooks as well. I guess what I would say is if you haven't heard about it, I would go check it out, and I'll tell you why here. So let me go close the poll. All right. So what is it? So a Jupyter notebook it's a set of technologies. It's all open source. And the idea behind a notebook is it's a way to organize your work. And a lot of InfoSec analysis is, go get some data, run some queries, get some data, and then start to interact with it, start to filter it, pivot it, enrich it, visualize it, and whatnot. And the notebook you could think of it, it's like a web page where you can type commands. And if you're familiar with Python, there's kind of like a Python REPL built into it where you can type some commands and then go fetch some data, and then you can start to interact with it. And you could deal with row set data. This is showing a Jupyter notebook that went and fetched some data from a system we have, and then is visualizing it in this, what's called a chord diagram at the bottom. And because Jupyter is built on top of the open source ecosystem and heavily uses Python, you can use anything in the Python universe for visualization, and I'll show you how that's useful in just a bit. So if you've never heard about it, do know that one, it's got a vibrant ecosystem behind it. I think there's now over 3 million notebooks on GitHub, so there's a ton of stuff out there for it. You can run it locally. You can run it in the cloud. Every cloud supports it: Azure, AWS, Google. And then a key thing about these notebooks is not just the tools they give you to analyze data, but the fact that once you analyze it, you can give it to you can share it. You can share that notebook. It's just a file. You can publish it on GitHub. You can share it with a colleague or another organization, and then they can rerun it and re-execute it. And for example, if you fetch data from your system and then process it, they could go rerun that and fetch it from their system and then go rerun it. And it's a very powerful way, because if you think about what often happens in the SOC is they're starting to look at something, they stare at a spreadsheet for a very long time, they click into the classic tools that they use, and then they come out with a conclusion, and they write up that conclusion in a ticket or in an email or a report. And you wonder, how did they get there? Like, what steps did they take? Did they leave anything out that was crucial? I would love to be able to do that, what they did. How could you possibly get closer without having to really, shoulder surf them or ride side saddle with them to gain that knowledge? And here, if you could do it in a notebook, it is possible for somebody to take that notebook and reuse it. One of the tools that we publish is called Mystic Pi. It's an open source tool. And what this is trying to do is, why Python has a great set of tools that are out there that work with data, certainly. Often there is a gap between making those tools work with security data specifically. There's a lot of visualizations out there that, pie charts, bar charts, line charts. That's great, but really what security people need are not necessarily those visualizations. They need more visualizing data as a graph, because a lot of data in your network has those dependencies and control relationships. Or you need to visualize things in a timeline or time series, because you're trying to trace some lateral movement. You need to go what happened over here to what happened over here to there. Or viewing parent-child relationships, and often you're investigating some process that started on a machine, and you want to know, well, what was the parent process of that? How did it get started? What child processes did it create? So that hierarchy is another important visualization, and Mystic Pi tries to apply that to security data to sort of simplify that. So these are some notebooks that use Mystic Pi and show how it's able to go take security data, visualize it, in this case, in a time series, to make it easy to try to spot outliers of, say, data transfers or exfiltration. This is trying to visualize a process hierarchy here, so you can scroll through it and kind of color it as you might. This is just taking observables, enriching them with open source threat feeds, and so on. So there's a number of notebooks already out there to get started with this. So one thing about notebooks that I think is also really interesting and important is, if you get to the point where you're able to build a notebook that analyzes something, say analyzes an alert, and often a SOC that uses notebooks, what they'll do is, okay, an alert happens and they need to commonly go get a bunch of initial context to help triage it. Let's give the analyst and start with some data and not just the raw alert. And notebooks often can embody those steps of getting that contextual data around it. So the analyst starts with a lot more situational awareness, and then they can, process that alert and then come to some conclusion with it. Well, once you come out with a good notebook that you say, hey, this is an awesome playbook. I want to run this every day. This is a great hunting hypothesis. Let's go run this every day, see what hits come out, and then do these set of steps of enrichment. Well, if you can implement it in the notebook, there's also a technology, open source technology called Papermill, which allows you to automate the running of notebooks. So that notebook essentially becomes something you can schedule, run, execute, parameterize, and get the output from. And the nice thing about this idea of Papermill, which was created by Netflix, because they do a lot of data science, machine learning, the use of Jupyter notebooks in the running of Netflix, is often in the SOC, when some SOC analyst wants to automate what they did, they have to sort of swivel over, talk to an engineer and say, hey, look, this is what I did. Can you automate this? So I don't automate this toil away, so I don't have to do this manually. That's a pretty typical flow. But here, what the speed up is if you can embody it in a notebook, now the SOC analyst can just schedule that notebook. And the tool they use to do the analysis now is the same tool they use for automation. And it really puts a SOC analyst in charge of their own productivity, and they're able to really start to speed themselves up because they have a way to sort of embody what they did and automate it. All right. So last topic here is community. So community runs through everything I talked about before. Everything I talked about is only there because of an open source, open community. This is an example of a YAR rule that I contributed to Florian's repository of YAR rules. One of the nice things about it is this was some Java, beanlet attack or something like that, where I was able to write a YAR rule to detect it. And when I contributed to his repository, that YAR rule is then run against every submission to VirusTotal, and it is annotated in the community or crowdsourced rule section of VirusTotal. So as a community member, you go, wow, great, I write a rule, and then everybody gets to benefit from the running of this rule against everything on VT, so they can go search for those things if they're interested in it. So that's pretty cool. How did this happen? So Florian and I, who runs this project, we've actually never met in real life. We finally met virtually for the first time, actually this morning, but we know each other through Twitter. But the way that I contributed this rule is because the project is hosted on GitHub. This is really about the power of the pull request, where I went there, tested my YAR rule, did a pull request, contributing it. And you can see kind of in the screenshot here, Florian's like, well, you could tweak your rule this way, tweak your rule this way or that way to improve it. And so I learned something about how to write a better YAR rule for it. So it was a great way to not only make a contribution, but I learned something in the process. And then one of the other initiatives I want to highlight that I think is a big community project is OSCD, which is which stands for Open Security Collaborative Development. And what this project is about, or initiative, is a set of sprints that they organize to try to harness the community sort of willpower to go, in some cases, like this one from last year, add a bunch of Sigma rules to cover missing, to fix missing coverage for MITRE attack techniques. And you can see the number of different people from all over the globe that contributed to it. On the right, the pull requests, the monster pull requests with all the changes at 144 Sigma rules that were contributed. So I think just a great example of harnessing the power of community to go provide coverage in these things. And there's another sprint that they just kicked off this month, October. And so there's a link there. You can go find the handle on Twitter and find out how to go get started. I made a couple of contributions already through it. So another great open project that's out there. So all of these techniques that I talked about today, one way I refer to them is the Githubification of Infosec. And the way to think about that is, imagine if every threat intel shop described the threat groups they cover in terms of the MITRE attack techniques that those threats use. And researchers everywhere contributed new and novel techniques that defenders need to know about to MITRE attack. And now we have a curated threat database simplifying the places defenders need to look to understand the attack techniques that they may need to worry about and focus on. And that every MITRE attack technique, imagine if it had a Sigma rule or YAR rule or SNORT signature for it, to speed the process of embodying how to detect the kind of attacks that are there, what log sources do you need to look at, and so forth. And then a robust set of translators inside the Sigma project to translate to the query tools that defenders use everywhere, whether that be ArcSight, Splunk, Elastic, Microsoft tools, you name it. And then for when defenders need to go and investigate those things, there's a Jupyter notebook already there. And all these techniques are really meant to leverage each other in a stack. They're not, while they are sort of standalone projects, they, in a way, if you stack these practices together, you go from knowledge amplified by executable know-how with Sigma, amplified by Jupyter notebooks that allows this repeatable, shareable, schedulable analysis in a way that I think will help speed every defender. So if there was a single thing that's like, well, if this idea took off and was successful, what would that mean? I would say, it would mean there's a MITRE attack technique for every attacker TTP, and we know which threat groups use which techniques. There would be a Sigma rule for every MITRE attack technique. There would be a Jupyter notebook for every kind of alert, so you knew how to go and investigate them. And so if you're interested in learning anything more about these, I have kind of put up some different things you can try. If you've never used Sigma, go check it out. If you've never tried a Jupyter notebook, go check it out. If you don't know Python, Jupyter also works with PowerShell and other languages. It has kind of like a kernel you can swap out. And so you don't have to use Python in order to make use of it, but that is sort of the natural language that's there. But there are other languages supported as well. If you push out advisories, consider publishing a Sigma rule with them. So a lot of different things I think people can use to get started in this area right away. And I'm curious to see if anyone has figured out the Easter egg in the presentation. If you're interested in more, there is on Medium, there is a full-length article on the Githubification of Infosec that I published there. And there's also a translation of it by the Russian-speaking Infosec community on the second site listed there. So with that, it's been great to be here. I look forward to being in person with you at the next SAS, and just be glad to hear from you about anything about my talk today. Thank you.